બરોબર છે. હા, દેખાય છે. બે મિનિટ પછી ચાલુ કરું, આવી જવાના હોય બધા આવી જાય. ચાલુ કરો કબીર.
હા મેમ, અવાજ તમને ને?
હા, ક્લિયર. કોણ કરે છે?
મેમ એક સેકન્ડ, હમણાં ફ્રીથી જોઈન થાય છે, એનું જ સ્ટાર્ટ છે.
સ્ટાર્ટિંગમાં કોણ બોલે છે?
પ્રીતિનું છે ને?
હા.
એ જોઈન થાય છે હમણાં, 2 જ મિનિટ.
Hello.
હેલો.
हाँ मैम.
ચાલુ કર.
Yes. So today we are going to discuss about aerobic and anaerobic blood consumption. Before we understand the details and how the system and the process works, first of all we will look at we are looking at the diagram of a treatment plant. Over here we can see that in the primary treatment there is a primary clarifier and in the secondary treatment there is a secondary clarifier, both of which release sludge. Next slide. If we look at the basic understanding of any plant, we know that there are two types of end products, that one of them is an effluent and the other is a sludge. Now, how is sludge useful, or why do we need to apply these kind of techniques and methods on sludge for its treatment? Sludge is basically a semi-solid compound which contains a lot of water content, which has a lot of water content, and Ma'am, एक second, हमारे net. Which has a lot of water content, and because of the presence of organic matter, it is also harmful in a larger quantity in case it gets mixed with drinking water or the groundwater. Because of this, sludge needs to be treated. Now, sewage sludge is large in bulk and contains putrescible substances and living organisms. If we treat this kind of a sludge, it is going to help us it is going to help us as a fertilizer, because after treatment, almost 60 to 70% of water retention from the sludge can take place, which is going to help in improving the quality of the sludge, which will eventually help us in further use. Next slide. The principal objective of sludge digestion is to subject the organic matter present in the settled sludge of the primary and final sedimentation tanks to an aerobic decomposition as to make it innocuous and amenable to dewatering on sand beds or mechanical filters before final disposal in any land, lagoon, or sea. There are two kinds of digestions that we can perform. That is aerobic and anaerobic digestion. Now, the principle of sludge digestion is basically to convert the organic matter that is present inside the sludge into and break it down into carbon dioxide and water, which can then be easily disposed of. If the sludge digestion is aerobic, then there is no end product like a gas that is released, which can be further used as a fuel. Whereas for anaerobic sludge digestion, fuel is the gases are released, which can further be used as fuel.
પ્રીતિ,
Yes, ma'am.
અહીંયા છે ને ડિફરન્સ નાખી દેજો, એરોબિક સ્લજ ડાયજેશન એન્ડ એનએરોબિક સ્લજ ડાયજેશન.
ma'am, એ પાછળ છે, મતલબ ડિફરન્સ ના
મેં લાસ્ટ
પણ છે.
ચલો હું જોઈ લઉં છું.
Okay. Kabir is going to explain sludge treatment processes.
Okay. So sludge treatment contains several 4 types of different stages. So first of all, thickening. It allows us to handle the sludge properly. The next one is digestion, required to reduce the amount of sludge in very less constitution. Digestion means we simply heat up the sludge and also kill any unwanted substance. Third one is dewatering. After digestion, sludge takes a lot of moisture, so dewatering is used to make it dehydrated so that we can produce like a powder or a sludge cake that can be utilized as a landfill laterwards. Thickening. The figure shows the gravity thickener in which the rotator is rotating at a very slow speed, and the sludge is passed through the scum skinner, and from the inflow pure water is passed, and some of the moisture which is present in the sludge is collected in sludge liquor, and the thickened sludge is collected beneath the beneath the rotor, and the thickened sludge is then collected. First of all, the water is provided through the inflow, then the water content from the sludge is transferred into to the sludge liquor. While the rotor is rotating at a very slow speed, the rest of the sludge is being settled down, which is called the thickened sludge. Second one is digestion. Sludge contains a lot of microorganisms and it is with a lot of order. So the best way to cure this problem is to heat up the sludge, and heating produces a huge amount of gas. So આના ઉપર ગેસ રિમૂવલની બી પાઇપ આપી છે, એટલે જેટલો બી ગેસ પ્રોવાઈડ થાય ને એટલે મેક્સિમમ અમાઉન્ટ ઓફ ગેસ એ ઉપરથી રિમૂવ કરી શકે. So after heating we have 3 layers inside the chamber. First one is scum layer that contains fat components, then supernatant, a lot of water content in the top because they receive a lot of moisture during the heating process. Second one is active sludge, and third one is stabilized sludge. So now the difference between active sludge and stabilized sludge is mentioned in the next slide. So active sludge contains microorganisms which provides nutrients to the microbes in the base part, which helps them to survive. And stabilized sludge, this does not contain microorganisms. Its chemical properties is also being modified, and it is modified so much that it is no longer be able to help and provide nutrients towards growing microorganisms in the secondary treatment. These are the huge sheeting chambers. By increasing the temperature inside these chambers, the active sludge is then converted into the stabilized sludge. The main aim of digestion process is to convert the active sludge into the stabilized sludge. So this conversion is done by these huge sheeting chambers in which the temperature is increased at a constant rate. So main aim of digestion chamber is to make stabilized sludge. Then the last one is dewatering. Dewatering means dewatering reduces the volume of the sludge so that it is easy to carry and we can minimize the transportation cost too. The dewatering word itself says that the water content or the moisture content from the sludge is taken out, not 100%, but mostly the water content is taken out from the sludge. 5 to 10% of water content already remains in that, so we can't that there is not any process to convert all the sludge into dry. So, and the last one is disposal, which I have not mentioned, and it also minimizes the transportation cost too. Then sludge digestion is explained by Kriti.
Sludge digestion. If we understand the basic concept as explained by Kabir, what sludge, after understanding sludge treatment, we specifically understand sludge digestion. What happens in sludge digestion, as I already said, that the basic concept or the principle is to break down the organic matter present in the sludge. Now, why do we do that? Generally, it is very difficult to transport sludge from one place to other for all kinds of reasons, specifically for the further use in the form of fertilizers or other fuel fuel uses. What happens in sludge digestion is that some portion of solids is converted into liquid and gases because the volume of the sludge is reduced by 60 to 75%. The moisture content of the sludge cannot be reduced easily, but after its digestion, it can be removed without any difficulty. Sludge digestion process removes coliforms by 99.8% by digestion. Coliforms are present in sewage sludge generally, and they're very harmful if they get mixed with groundwater. That's why sludge digestion is used to remove coliforms by a extremely large percent. There is the entire and there are two methods of sludge digestion, which is aerobic and anaerobic. If we look at the anaerobic conditions, it happens in the presence of two kinds of bacteria. The first group of bacteria is going to attack the organic substances present like fats, carbohydrates, proteins, and it will convert them into organic acids and alcohol. The second group of bacteria that is present is going to convert this acid and alcohol that is formed into further carbon dioxide and methane, and along with gases. These gases released can further be used as fuels. Next slide. Now, over here, as we have seen, that if we look at certain conditions like uncontrolled and slow conditions, sludge digestion takes place in three ways. Acid production, as the first bacteria attacks, acid production happens. Acid regression, where the acid is used by the second bacteria, and the period of intensive regression. This is when the sludge digestion actually takes place and converts the organic matter present into methane and carbon dioxide. In anaerobic conditions, it is going to convert into gases which can further be used as fuels. And in aerobic conditions, it is going to convert only into methane and carbon dioxide. Next slide. I've already said this. Next slide. This will be explained by Lakshmi.
Yes, so basically, since Kriti already explained, there are two types of sludge digestion, aerobic sludge digestion and anaerobic sludge digestion. I'll give you a brief about what aerobic sludge digestion exactly means. Aerobic treatment of wastewater is a biological process that uses oxygen to break down organic contaminants and other pollutants like nitrogen and phosphorus. Basically, oxygen is continuously mixed into the wastewater or sewage present by any mechanical aeration device, for example, air blower or a compressor. It uses bacteria that requires oxygen So the air is circulated throughout the treatment tank, and the aerobic bacteria breaks down the waste in the wastewater. Aerobic digestion may be used to treat waste activated sludge or waste activated sludge and primary sludge or waste sludge from extended aeration plants. These are the three different possibilities when aerobic digestion may be used. Next. The basic working principle of aerobic digestion is as follows. An aerobic treatment plant is the decomposition of raw sewage. The process is done by aerating the sewage chamber with oxygen. The aerobic bacteria survive on this fresh air and decompose the raw sewage, which can be disposed of in the sea. Next. Basically, before we begin the main treatment of aerobic sludge digestion, there is a little pre-treatment process which includes the reduction of the size of solids, so the aerobic bacteria can easily break them, and there are lesser chances of the system being clogged. Then begins the main treatment. It treats household wastewater and includes both domestic gray and black water. As I already said, through a compressor, air is forced into the sludge or the wastewater where aerobic bacteria can feed on it. Next. Solid waste that bacteria cannot settle out as sludge. Some aerobic treatments include secondary settling tank where this undigested sludge portions are shifted and treated again. After the treatment, the final stage is the final treatment or disposal. So this is removed. The sludge is frequently pumped out of the system to reduce the opportunities of clogging the system. Next. This is the basic construction of the aerobic sludge digester from the front and back. Next. There are various factors that play an important role in any sludge digestion process, be it aerobic, anaerobic. Various factors include temperature, solid reduction, tank volume, oxygen requirements, etc., which will be explained in detail by Zenith in the end. Next. The basic process of sludge digestion. As it has been repetitively said that during sludge digestion, artificially air is being included in air is being supplied to the chamber and the bacteria feed on the air. The process can be divided in can be written as 5 different reactions, as 5 different steps, which we'll see in the next slide. Next. These are the 5 different reactions in which the aerobic sludge digestion process can be explained. The first one being biomass destruction. Due to addition of oxygen, formation of carbon dioxide and water is formed. The next step is the nitrification.
Hello.
Yes, ma'am.
આમાં જે ફર્સ્ટ ઇક્વેશન છે ને C5H7NO2 એ શું ઇન્ડિકેટ કરે છે? એ બાયોમાસનો કેમિકલ ફોર્મ્યુલા ને બાયોમાસ એનું બનેલું હોય છે તો એ બેક્ટેરિયાનું બનેલું હોય છે, લિવિંગ બેક્ટેરિયા. એટલે આ કેમિકલ ઇક્વેશન છે બેક્ટેરિયાનું. C5H7NO2 is a chemical formula
for
bacteria, living bacteria. Okay.
Yes, ma'am. So as in the process of aerobic digestion, the bacteria uses up the oxygen. So due to addition of oxygen, we'll receive NH4, HCO3, H2O, and CO2. The second reaction being nitrification of the released ammonia nitrogen. So NH4 plus oxygen plus nitrogen trioxide plus hydronium ions will conduct the reaction. The overall equation with the complete nitrification process will go like the same living bacteria formula. C5H7NO2 plus oxygen will give 5CO2 plus H2O plus HNO3, which is nitric acid. The next reaction is using nitrate nitrogen as electron acceptor, or this process is also known as the process of denitrification. So to C5H7NO2, we add nitrogen trioxide ion and water to give hydrogen carbonate as the process of denitrification occurs. And the last reaction being with complete nitrification, C5H7NO2 plus oxygen will ultimately react to give carbon dioxide, hydrogen, and removal of nitrogen. Next. There are various advantages and disadvantages of both the processes. For aerobic sludge digestion, the advantages involve sustainability for digesting nutrient-rich biosolids, lower BOD concentrations in supernatant liquor, recovery of more of the basic fertilizer values in the sludge. Operation is relatively easy and it has a lower cost. Next. There are certain disadvantages of aerobic sludge treatment, which include a higher power cost if the oxygen supply we use is of a higher cost. If the compressor we use consumes a high power, then the cost of the machinery will increase. The second disadvantage is digested biosolids produced have poorer mechanical dewatering characteristics, and useful byproducts such as methane is not recovered in the process of aerobic sludge digestion. So these were the certain advantages and disadvantages, some of which are overcome in anaerobic treatment, which will be explained by Yash. Next.
Hello. Hello.
Yes, Yash.
बरोबर.
So, as explained earlier, anaerobic sludge digestion is a process in which a large fraction of the organic matter is broken down into carbon dioxide and methane, and this is accomplished in the absence of oxygen. About half of the amount is converted into gas, and the remaining half is dried and becomes a residual soil-like material. This process is generally recommended for treating wastewater with high strength, that means which has high value of BOD or COD. The figure shows the generation of sludge from the primary and secondary treatment of wastewater. And anaerobic digestion is the most widely employed method for sludge treatment. Next. Anaerobic sludge digestion is usually performed in a biodigester, as shown in the figure, which is an air and water type equipment which is closed at top and has a conical bottom. The main goal of this biodigester is to reduce the biological and chemical reactivity of the sludge. Now, as shown in figure, the tank is closed at the top to prevent oxygen from coming in, odors from escaping out, and to capture the methane produced in the process. Now, this methane captured can be used as a fuel later to meet the energy requirements of the treatment facility. In India, generally, high rate digestion is done, which is explained later, in cylindrical tanks of RCC with depth to diameter ratios of 0.5 to 0.7 with conical bottoms. Next. Process. The figure shows the schematic diagram of two-stage high-rate anaerobic sludge digester. This process is known as methane fermentation of anaerobic sludge stabilization, and it can reduce the organic matter content up to 40 to 50%. Next. Basically, there are two types of anaerobic sludge digestion processes. They are low rate digestion and high rate digestion. In low rate digestion process, the feed enters the active zone in a large storage tank without reheating. Then heating is provided and all processes are done simultaneously without mixing of the sludge, which affects the efficiency and produces the digested sludge at low rate. While high rate digestion, which is an extensively used process, the raw sludge enters the tank, goes through the process of thickening beforehand, by which the volume of the free water reduces, hence making the process faster. In both these processes, some heating is provided to accelerate the biological conversion. Now, the sludge feeding or the organic loading rate is expressed in terms of volatile solids.
હેલો હા એક વસ્તુ અહીંયા કહેવાની છે લો રેટ ડાયજેસ્ટર અને હાઈ રેટ ડાયજેસ્ટર એ બંને વચ્ચે મેઇન ડિફરન્સ શું છે તો લો રેટ ડાયજેસ્ટર ની અંદર ખાલી એક જ ટેન્ક હોય અને જે બી સ્લજ આવે જે બી સ્લજ એટલે પ્રાઇમરી સ્લજ હોય કે સેકન્ડરી સ્લજ હોય એ બધાને એક ડાયજેસ્ટર ની અંદર 30 થી 50 દિવસ માટે મૂકી રાખે બરોબર એમાં કોઈ મિક્સિંગ પ્રોવાઈડ ના કરે જનરલી એની અંદર હીટિંગ બી પ્રોવાઈડ કરવામાં આવતું નથી એટલે પ્રોપર મિક્સિંગ ના થાય પ્રોપર હીટિંગ ના થાય એટલે નેચરલી પ્રોસેસ થાય એમાં કોઈ એડવાન્સમેન્ટ નથી હોતા એટલે જે ઓર્ગેનિક મેટરનું કન્વર્ઝન મિથેનમાં થવું જોઈએ કમ્પ્લીટ મિથેનમાં એ ઓછું થાય મતલબ એફિશિયન્સી ઓછી છે એટલે એને લો રેટ ડાયજેસ્ટર કહે છે જ્યારે હાઈ રેટ ડાયજેસ્ટર ની અંદર ટેન્ક હોય એક ટેન્ક પહેલી જે ટેન્ક હોય એની અંદર જસ્ટ થિકનિંગ જેવું થાય અને બીજી જે ટેન્ક છે એની અંદર એ પોર્શન જાય થિકનિંગ વાળો પોર્શન એટલે એમાંથી વોટર પોર્શન થોડો ઓછો થઈ જાય અને એ થિકનિંગ પોર્શન ની અંદર પ્રોપર મિક્સિંગ બી કરે અને હીટિંગ બી કરે એટલે ત્યાં એસિડોજન્સ અને મિથેનોજન્સ એ બંને રિએક્ટ કરશે બરોબર અને એમાં મિથેન ગેસ પ્રોડક્શન વધારે મળે એટલા માટે એને હાઈ રેટ ડાયજેશન કહે ચલો કન્ટિન્યુ
હા મેમ explain next slide રાખી એટલે
ઓકે 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 હા
so the sludge feeding is expressed in volatile solids, and for low rate digestion it is 0.5 to 0.6 kilogram volatile solids per meter cube per day, and for high rate digestion it is 3.2 to 7.2 kilogram. The retention time is usually about 1 month, but it can range from 15 days to 40.
હેલો
Yes ma'am.
હા હજુ હાઇડ્રોલિક રિટેન્શન એટલે શું હાઇડ્રોલિક રિટેન્શન ટાઈમ ની જે આપણે મેં તમને હમણાં છેલ્લે ચલાવ્યું હતું સેડિમેન્ટેશન ટેન્કની ઇટ ઇઝ વન ઓફ ડિટેલ કેટલા માટે સેડિમેન્ટેશન ટેન્કમાં માટે કે હોય અને એટલે આ HRT એક ટાઈપનું છે ઓકે હેલો
So
Yes.
ma'am.
કન્ટિન્યુ
Hello. Okay.
કન્ટિન્યુ
To sum up the whole process can be expressed and explained in 3 chemical reactions, namely hydrolysis, acetogenesis, and methanogenesis. Now, in hydrolysis, the carbohydrates, fat. હા મેમ આ જ સ્લાઇડમાં છે
સ્લાઇડ બદલાઈ
મેમ આ ઓલી લો રેટ અને હાઈ રેટ વાળી છે એટલે સ્લજ ફીડિંગ વાળું છે ને એમાં જ એક્સપ્લેન કરું છું જી
ઓકે હા વાંધો
In hydrolysis, the carbohydrates, fats, oils, and proteins present in the organic matter are converted into short-chain organic acids. These short-chain organic acids are then converted into acetic acid in acetogenesis. Now, this acetic acid is then converted into biogas like CH4, CO2, and with some trace amount of hydrogen sulfide and H2 gas. This process is called methanogenesis, and these 3 reactions constitute the whole process of anaerobic digestion. Next slide. Sorry, આ જ slide રાખજે.
હા સાંભળ યસ યસ આજે તે કીધું ને હાઇડ્રોલિસિસ એસિટોજેનેસિસ અને મિથેનોજેનેસિસ આ 3 પ્રોસેસીસ એ હાર્ટ છે આખી એનેરોબિક ડાયજેશન નો બરોબર એટલે અહીંયા એક અલગ સ્લાઇડ એડ કરજો આ જે છેલ્લો પોઈન્ટ છે ને હાઇડ્રોલિક રિટેન્શન ટાઈમ એ ત્યાંથી કાઢી દો અને એક નવી સ્લાઇડ એડ કરો. હાઇડ્રોલિસિસ માં શું થાય તેમ તે જેમ કન્વર્ઝન કીધું એમ, પછી એસિટોજીનેસિસ માં શું કન્વર્ઝન થાય અને મિથેનોજીનેસિસ માં, એટલે એક ટેબલ જેવું બનાવી દો કે આમાં આનું કન્વર્ઝન આમાં થાય, આનું કન્વર્ઝન આમાં થાય, અને વિચ બેક્ટેરિયલ સ્પીસીઝ આર રિસ્પોન્સિબલ એ બી તમને ક્યાંકથી મળી જશે.
હા મેમ.
બરોબર,
એક
અહીંયા એક સ્લાઇડ એડ કરી દો આના પછી. ચલો નેક્સ્ટ.
Now, the hydraulic retention time is directly related to the extent of each of the three reactions occurring during anaerobic digestion. So, the retention time is dependent on the time of the process, these three reactions occurring. Now, this process can either be thermophilic digestion or mesophilic digestion. In thermophilic digestion, the temperature is around 55 degrees Celsius, and in mesophilic digestion, it is around 36 degrees Celsius. Next slide. Now, the process can be designed with a batch or continuous configuration, or in either single stage or two stages. Now, in batch configuration, the sludge feeding is done at the starting of the process, and in continuous configuration, the sludge is continuously fed throughout the process. The figure shows single stage and two stage high rate and two stage digestion. In single stage digestion, the raw sludge gets in the active zone and some heat is provided to it. The mixing does not occur in single stage, so that the mixing is not. Hello.
હા બોલો બોલો.
Net na thoda issue છે. The mixing
હા
is
બોલો.
not here, so that the sludge produced is in low rate because the thickening is not provided. The sludge, the digested sludge obtained is then collected from the bottom, while the methane gas produced is collected from the top. The scum and supernatant is removed from the tank from exit. While in two-stage digestion, the sludge first enters the sludge first enters in the first tank, where all the incoming flows of sludge are combined and the mixture is heated to a mild temperature to accelerate the biological conversion, and the residence time here ranges from 10 to 20 days. Then after the residence time, it goes to the second tank, where the mixture is allowed to undergo further digestion. There is no longer active mixing in order to promote separation, and there is no need of heating as the process generates its own heat. Then after the digested sludge is produced, it is then taken from the bottom and gas from the top. Next slide. Now, according to the manual on sewerage and sewage treatment part A engineering, anaerobic digestion is considered to be preferred option under Indian condition because the process generates methane, which can be used as a fuel to produce electrical energy, while aerobic treatment needs oxygen by the means of aeration, which requires electrical energy. Also, anaerobic digestion requires the temperature in the range of above 25 degrees Celsius, which is available throughout India and throughout almost the whole year. Now, advantages of it reduces the production of landfill methane, a greenhouse gas. Disadvantages. In this process, heavy metals and contaminants are accumulated in sludge. The whole plant has a high capital cost. Also, it requires skilled and qualified manpower for the design, construction, and operation and maintenance of the facility. The optimal reaction conditions are highly complex to maintain. Next slide. It is the key differences between aerobic and anaerobic process. So, the application, first point is application. In which wastewater can aerobic or anaerobic treatment be applied? So, An aerobic treatment can only be applied when the wastewater has low to medium strength, that is less than 1000 ppm. Some examples: municipal sewage, refinery wastewater. Now, when the wastewater has strength greater than 4000 ppm, that is from medium to high strength, anaerobic treatment is used. Food and beverage industry wastewater has this kind of high strength. Capital investment for aerobic treatment is relatively high because of the compressor or the aeration tank, while anaerobic treatment has relatively low capital investment because we get a payback of methane which is used as a fuel. Energy consumption is high in aerobic treatment because it provide the air and low for the anaerobic treatment. The footprint for aerobic treatment is large, while for anaerobic treatment is small and compact. The net sludge yield is high for aerobic and low for anaerobic as it almost digests 50 to 60% of the wastewater sludge. Now, for aerobic treatment, post treatment is not required and it is directly discharged into the sea and for anaerobic treatment, it is required to fulfill the wastewater standard discharge requirement. Some examples of aerobic treatment are activated sludge process, trickling filter, and rotating biological contractor. And for anaerobic, they are anaerobic digesters, continuous stirred tank reactors, sequencing bench reactors, and anaerobic sludge blanket reactors. Next, factors affecting sludge digestion will be explained by Zenith.
Hello.
Hello.
So I'm going to explain the factors affecting the sludge digestion. So the important factors which affect the sludge digestion process, the process which we have already seen in the previous slides, are temperature, pH value, seeding with digested sludge, and mixing and stirring of raw sludge with digested sludge. So these all factors are explained in the next slides. Next slide, please. So the first factor affecting the sludge digestion process is temperature. So the process of digestion is the process of digestion is greatly influenced by temperature. So the rate of digestion is more at higher temperature and vice versa. So at higher temperature, the rate of digestion is more, and with lower temperature, the rate of digestion decreases. Temperature also affects the gas transfer rates and sludge settling properties. Maintaining suitable. Hello.
Hello.
Net to do.
મને બરોબર આવે
Hello.
છે અવાજ તો બરોબર આવે છે.
Okay, chalo.
So maintaining suitable operating temperature is important as methogens are sensitive. Methogens are organic microorganisms that produces methogens, and they are affected by temperature of greater than 1 degree Celsius, change in temperature of greater than 1 degree Celsius per day. Next slide. So there are two distinct zones of digestion as shown in the figure. The figure is shown of temperature in degrees Celsius versus the time in days for the digestion. The upper curve is thermophilic digestion and the lower curve shows mesophilic digestion. Thermophilic digestion has an optimum temperature of 54 degrees Celsius and mesophilic digestion has 29 degrees Celsius optimum temperature. So this creates two zones, zone of thermophilic digestion and zone of mesophilic digestion, which are explained in the next slide. So the zone of thermophilic digestion. So in zone of thermophilic digestion, the thermophilic organisms that are the organisms which are thermophilic or heat loving in their nature, and these are more active and it ranges from 35 degrees Celsius to 60 degrees Celsius. The optimum temperature in this zone is 54 degrees Celsius, and at this temperature, the digestion period can be brought down to about 7 to 10 days only, as it takes a lesser time. The next zone is zone of mesophilic digestion. In the zone of mesophilic digestion, the common or mesophilic organisms at moderate temperature are more active, and its practical range is 26 to 35 degrees Celsius, and optimum temperature in this zone is 29 degrees Celsius. So at this temperature, the digestion period can be brought down to about 30 days. Next slide. The second factor affecting the digestion of sludge is pH value. Desired pH range for the effective digestion of sludge is 6.8 to 7.2. If the pH value is more than 7.2 or lesser than 6.8, to maintain the pH value within this range, the following remedies are applied. These remedies are adding lime or sodium carbonate or sodium bicarbonate, or introducing the required quantity of raw sludge, or controlling the removal of digestive sludge. Dissolved carbon dioxide produced by the digestion of soluble organic matter consumes alkalinity, and this also shows the alkalinity levels in biogas. Next slide. The third factor is seeding, which with digested sludge. So first and foremost, what is sludge seeding? So process of introducing fresh sludge in previously well digested sludge is sludge seeding, and it should be done in such a way that the alkaline condition may prevail in the tank. Usually about 2.5 to 3.5% by weight of fresh dried solid is in dry digested sludge could be added per day, so as to maintain the pH value of about 7.1%. Lime may be used for the purpose of attaining the desired pH, as we saw in the previous slides. And in this case, the above percentage can still be increased to about 5.5%. The proper seeding of sludge develops a favorable condition for MO and digestion of sludge that takes place in the short period. Next slide. So the fourth and the last factor affecting the sludge digestion process is mixing and slurring of raw sludge with digested sludge. So incoming fresh sludge should be thoroughly mixed and digested with the digested sludge by some effective method like mechanical agitation. The proper stirring results in even distribution of incoming sludge, maintenance of uniform temperature in tank, reduction of scum, increase in the production of biogas. There are some miscellaneous conditions, other factors which influence the process of sludge digestion. These are quality of public water supply during the process, and the presence of copper, fluorides, radioactive substances during the sludge digestion process. Next. Thank you. This is the end of our presentation.
ઓકે હા પ્રેઝન્ટેશન માંથી એ કરી દો સ્ક્રીન શેર માંથી આ જે પ્રેઝન્ટેશન હતું એ તમારે બધાએ ધ્યાનથી વાંચવાનું છે કારણ કે લાસ્ટ જે ચેપ્ટર છે સ્લજ ટ્રીટમેન્ટ એમાંના બે પોઈન્ટ છે એરોબિક સ્લજ ડાયજેશન એન્ડ એનએરોબિક સ્લજ ડાયજેશન બરોબર એની આગળનું જે પોર્શન છે વોટ ઇઝ સ્લજ what is volume and mass relationship of sludge એ તમને અમૃતા મેમ કરાવશે કમ્પ્લીટ ઠીક છે એમનું કદાચ એઈઆઈ નું પોર્શન એમના સાઈડ નું કમ્પ્લીટ થશે પછી માસ એન્ડ વોલ્યુમ રિલેશનશિપ ઓફ સ્લજ અને એના એક્ઝામ્પલ્સ છે એ અમૃતા મેમ કરાવશે અને એ પછી આ પોઈન્ટ છે એરોબિક સ્લજ ડાયજેશન એન્ડ એનએરોબિક સ્લજ ડાયજેશન બરોબર તો આ તમારે જાતે કરવાનું છે આ પ્રેઝન્ટેશન છે એમાંથી અને યશ મેં જે પ્રમાણે ચેન્જીસ કીધા ને એ પ્રમાણે કરી દેજો ચેન્જીસ બીજી એ સ્લાઇડ થોડી ડિટેલમાં લખજો બીજેથી મટીરિયલ લેજો બરોબર હાઇડ્રોલિસિસ શું છે પછી એસિટોજેનેસિસ શું છે અને મિથેનોજેનેસિસ બીજો પોઈન્ટ તમે છેલ્લે જે લખ્યું ને એરોબિક એન્ડ એનએરોબિક પ્રોસેસીસ નો ડિફરન્સ છે. તમારે શેનો
હા
ડિફરન્સ લખવાનો છે? એરોબિક સ્લજ ડાયજેશન એન્ડ એનએરોબિક સ્લજ ડાયજેશન નો ડિફરન્સ લખવાનો છે. તમે જે ડિફરન્સ લખ્યો છે ને એ એરોબિક પ્રોસેસીસ અને એનએરોબિક પ્રોસેસીસ નો છે. એટલે એ સ્લાઇડ કમ્પ્લીટલી રિમૂવ કરી દેજો અને એની બદલે એરોબિક સ્લજ ડાયજેશન અને એનએરોબિક સ્લજ ડાયજેશન નો ડિફરન્સ એક વખત મને બતાવી દેજો રફમાં લખીને. કોઈ એક જણ મને વોટ્સએપ કરી દે અને એ છે ને એરોબિક સ્લજ ડાયજેશન નું સ્ટાર્ટિંગ થાય ને એ પહેલા મૂકવાનું છે. બરોબર?
ઓકે.
હા, એટલે આટલા ચેન્જીસ કરી દેજો. ઠીક છે?
હા મેમ ઠીક છે.
હા, શું શું કીધું મેં?
એક તો
એક તો
ડિફરન્સ.
હા,
તો
એ
એરોબિક
સ્લજ
એનારોબિક નો ડિફરન્સ.
ડાયજેશન એરોબિક ને એનએરોબિક સ્લજ ડાયજેશન નો ડિફરન્સ.
હા હા.
પછી
હાઇડ્રોલિસિસ, એસિટોજેનેસિસ અને મિથેનોજેનેસિસ નો આખી એક સ્લાઇડ
એ
બનાવી.
આખી હા, તમને છે ને એ નેટ ઉપરથી બી ફ્લો ચાર્ટ ના ફોર્મમાં બી મળી જશે.
હા મેમ
એક સ્લાઇડ થાય તો વાંધો નથી, એડ કરજો. અને બીજું આ એરોબિક એનએરોબિક સ્લજ ડાયજેશન ના ડિફરન્સમાં એક તો પહેલો તો પોઈન્ટ આવશે કે એર રિક્વાયરમેન્ટ છે, પેલામાં આવશે એર રિક્વાયરમેન્ટ નથી. બરોબર? પછી એરોબિક સ્લજ ડાયજેશનમાં કયા ટાઈપના બેક્ટેરિયા રિસ્પોન્સિબલ છે, એનએરોબિક સ્લજ ડાયજેશનમાં કયા ટાઈપના બેક્ટેરિયા રિસ્પોન્સિબલ છે. એ રીતે લખવાનું છે તમારે. બરોબર? એન્ડ પ્રોડક્ટ આમાં શું આવશે? એન્ડ પ્રોડક્ટ એનએરોબિક સ્લજ ડાયજેશનમાં શું આવશે? એરોબિક સ્લજ ડાયજેશનમાં આવે કાર્બન ડાયોક્સાઇડ એન્ડ વોટર, પેલામાં આવે મિથેન કાર્બન ડાયોક્સાઇડ એન્ડ વોટર. બરોબર? પછી
હા
એરોબિક સ્લજ ડાયજેશનમાં એનર્જી રિક્વાયરમેન્ટ જોઈએ એરોબિકમાં, એનએરોબિકમાં એનર્જી રિક્વાયરમેન્ટ નહીં જોઈશે. ઉપરથી એનર્જી પ્રોડ્યુસ થશે. એટલે એ રીતે તમારે ડિફરન્સ લખવાના છે. બરોબર?
હા હા બરાબર.
અને પછી મને મેલ કરજો ફાઈનલ પ્રેઝન્ટેશન. બીજું ફાઈનલ પ્રેઝન્ટેશન જ્યારે તમે મેલ કરો ને ત્યારે તમે ઓલું બેકગ્રાઉન્ડ ની અંદર પેલી સ્લાઈડો મૂકી છે ક્લેરિફાયર વાળી, એ
હા
ઉડાડી દેજો. વાંચવામાં તકલીફ પડે છે.
ઓકે
બ્લેક
મેમ.
એન્ડ વ્હાઈટ, બ્લેક એન્ડ વ્હાઈટ અથવા તો જે તમારું ઓરિજિનલ છે એમાં પણ પાછળથી ઓલી ઇમેજ ઉડાડી દેજો ક્લેરિફાયર ની. વાંચવામાં બહુ જ તકલીફ પડે છે. ઓકે?
હા મેમ.
આટલું વ્યવસ્થિત થઈ જાય પછી હું યસ કરું ને પછી તમારા ક્લાસમાં આ પીપીટી બધાને ડિસ્ટ્રીબ્યુટ કરજો. કારણ કે આ સિલેબસ નો પાર્ટ છે એટલે, અને હું નથી કરાવવાની. ઓકે? હા. એક મિનિટ. નાઉ યુ કેન લીવ.